Hello and welcome to Bridging Operations and Development with Observability, presented by Datadog. I'm your friendly neighborhood moderator. My name is Mike Vizard, and today we're going to be talking with Rick Sherman, who is the technical evangelist for Datadog. And I would say there's two important things you need to remember right now. The first is there's a chat bar up there that you can click on to ask a question, and that's going to be the way that this presentation becomes interactive later on. Rick has a lot of expertise, and it's being made available today for free, which is amazing. And then on top of that, we have 4 $25 Amazon gift cards that will be presented to the lucky winners at the end of the presentation. So make sure you stay tuned to the very end to see if you won. And with that, I'm going to hand it over to Rick, and let's have a great show, guys.
Awesome. Thank you, Mike. And welcome, everyone. Thank you for viewing this webinar. As Mike mentioned, my name is Rick Sherman, and I'm a technical evangelist at Datadog. And so in this webinar, I'm going to cover a couple of concepts. The first of which is using infrastructure as code to manage applications that are going to be in multiple production and development environments. And then leveraging that infrastructure as code to introduce monitoring and observability during the development process so that we can enable our developers to detect issues prior to deployment and then ultimately build a bridge between them and operations. And so I'm going to start off with a few slides to set the stage, but admittedly this webinar is going to be fairly demo heavy. And so a quick introduction to who Datadog is. Datadog is a monitoring and analytics platform. It provides full visibility across your organization and spans end-to-end from your infrastructure and network to your applications and services, all the way to your users. And the idea is to enable everyone. So ops, devs, security, even folks in the business to understand what's happening with your systems and your applications and to give them a view into the business from a technology perspective. And so Datadog does that by connecting your metrics, traces, and logs together so that you can see what's happening across the board. And so you can view metrics from your infrastructure, applications, or even your users. And then you can easily correlate that with traces that follow your code path from your browser, from your users' browsers, all the way through to your backend systems and data stores. And then you can view this together with logs that were generated from your systems during those same times. And so we can provide you all the information that you need in one tool so that you can quickly pinpoint problems and resolve them. But Datadog isn't just reactive, it's also proactive, and we include intelligence to help you know about problems often before they occur. And so with anomaly, forecast, and outlier detection, you can set intelligent alerts to reduce false alarms and reduce pager fatigue. And our machine learning powered watchdog will automatically look for potential issues across your systems and notify you of problems that you would have otherwise overlooked. And so there's our URL if you want to learn a little bit more. But now we're actually going to get into kind of the meat of the webinar itself. And I'm going to use a fictitious company to tell a story because I like to tell stories with my demos. And so we're going to talk about Storedog. And so Storedog is a cloud native e-commerce company. And they've built an e-commerce application. So being cloud native, it's fully containerized, has various components and services. So on the front end of Storedog, we have a Ruby on Rails application that includes some caching and some data stores. We have a couple microservices that are going to do things like process discounts and serve up ads. And then we have a shared database to support those microservices. And so Storedog was originally built locally with somebody on their laptop using Docker and Docker Compose, but now the application's in production and running in Amazon Web Services inside of Elastic Container Service with EC2. And the team was ahead of the curve, and they built all of this out with Terraform. And so they're managing the entire set of infrastructure with Terraform, starting with the VPC, ECS, load balancers, Route 53, the whole thing. But they're also deploying their application with Terraform. And so they are able to create multiple development environments within AWS for the different iterations of their application, and they look just like production. And so Storedog is really, like I said, ahead of the curve. They're doing great, seeing a lot of early success in the market, so everyone is really happy. But then the tweets start coming in. And so Storedog is clearly having some growing pains, and no one really saw it coming. And so operations does not have proactive monitoring, and the development team is now scrambling to find the root cause of seemingly multiple issues. And so the business of Storedog needs these problems resolved, and honestly, they can't afford to be taken like this by surprise again in the future. And so I'm actually going to go over to a live demo where we're going to spend a little bit of time going over the Storedog deployment, integrations with Datadog in their multiple environments, and then using Datadog to help them diagnose their issues and create proactive monitors for the future. And so for full disclosure, and the sake of time, the infrastructure and the environments have already been deployed, and we do have the Datadog integrations enabled, but I'm going to go over how that was achieved. And so I'm going to start the demo here within the AWS console, because if you may not be familiar with how ECS works, we're going to give a quick rundown on that. And so ECS is a collection of clusters. A cluster encompasses compute resources that are going to be running Docker. And so by using ECS, we can actually orchestrate applications across different clusters and handle the scaling like you would with traditional Amazon Web Services. So we need to scale up our compute, we need to scale up our load balancing. All of that is actually handled and orchestrated within ECS. And so I've got two different clusters here right now for Storedog. We've got one in production, which is running our production version of the application, and one in development. So I'm going to drill into the production cluster, and we're going to talk about some of the concepts that build up ECS. And then we're going to show how to actually do that with the infrastructure as code. So I'm actually going to skip one over here because we're going to look at the physical EC2 instances that are comprising this particular cluster. So I've got two EC2 instances that are running with a particular size and their Docker version. That's comprised of tasks. So tasks is a definition very similar to Docker Compose, where we actually say, my service is comprised of the following containers with the following resource constraints, ports, all of that. And then those get combined with services. And so services is the orchestration layer within ECS that says, I need N number of these tasks and I need them deployed across my compute nodes in a specific way. And so there's a lot of different moving parts into ECS. This is just kind of a quick overview into it. So you want more information on that, I definitely welcome you to dig in and see what you can learn there. But so we've got this ECS cluster built, and I mentioned it was done with Terraform. So I'm going to go through the Terraform module that I used to create all of this infrastructure. So my Terraform module is comprised of 3 levels in a hierarchy. At the very root of our Terraform module, we have things that are going to affect AWS and Datadog account-wide. And so these are things such as IIM roles. So here I'm building an IIM role for ECS itself. So ECS requires a certain level of functionality to be able to connect things like EC2. And so we're describing all of those IIM roles with Terraform. We also have some IIM roles for our integration with Datadog. So when we get to the Datadog side, we're going to see what a AWS integration looks like with Datadog. But at a high level, Datadog is able to connect directly to AWS and gather metrics from your account. And so that also requires some IIM roles. So here I have them described within my Terraform code, as well as the integration itself between Datadog and AWS. I'm going to show how that might be done manually or through our wizard when we get to the Datadog portion. And so at the next level, we have our infrastructure. And so this is the compute layer. This is the physical underlay that's building our application. And so I'm going to start at the VPC because that's kind of like the first step when you get to AWS. And here's a resource where we're actually building the VPC itself. And so I want to call out that I'm using this variable here for Terraform workspace. And for those of you who are not necessarily familiar with Terraform, Terraform keeps state. So it actually looks at your desired state. So what are the resources that you want to be created against what's actually in existence? So that's how it decides what to create, update, or delete, and then it saves that for subsequent runs. Terraform actually allows you to have multiple copies of that state and save them in discrete workspaces. So this actually allows us to have the do not repeat yourself principles where we actually are reusing the same Terraform code over and over, but we're able to generate different environments with them. And so here's actually how I'm determining whether or not I'm in a production or a development workspace, and then some variables that reflect those different particular environments. So we've got the VPC itself, we're building things like subnets or internet gateways, route tables and their associations, and so forth. So we go another layer up, we're actually going to look at the EC2 definitions within Terraform. And so here we're actually building launch templates. And so this is how we're actually determining what EC2 instances we want to spin up. And so I'm bringing up AMD smalls, we're doing some public IPs, and we're also even doing the user script for ECS. So to associate an EC2 instance with ECS, we need something in the hosts file in the ECS config. And so we're actually injecting our Terraform variables into that at runtime. On top of EC2, we're also using ALBs. And so we actually have one ALB per environment. And so in this case, we're going to have one in production and one in development. And then we'll actually go through and see how we're adding our application to that when we get to the application itself. Next, we have the ECS cluster. This is actually a very basic resource. And so now we're going to get to the ECS agent. And this is actually the Datadog agent within ECS. So I mentioned the task definition is fairly similar to a Docker Compose. And this is where we're going to look at the task definition for a Datadog containerized agent. So we've got the Docker image that we're going to use, some resource constraints. We're going to inject environment variables into this container. So in this example, it would actually inject the API key that we need to send our resource information to Datadog itself. Things like mount points, port mappings, volumes, all of those things that you would traditionally see within a Docker Compose file. And so once we've defined what a task looks like for the Datadog containerized agent, then we need to deploy that as a service within ECS. And so here I've got my ECS service block, and I'm actually defining a particular deployment strategy. And so with ECS on EC2, we want the Datadog containerized agent to be installed and running on every single EC2 instance. So this is the scheduling strategy that we're using here. And what that's going to do is actually put the containerized Datadog agent on all of those nodes, and it's going to immediately start getting us system level information about those EC2 instances. So things like compute, CPU, memory, network, disk. It's also going to hook into the Docker daemon that's running on that particular EC2 instance and give us information about how Docker itself is performing on that box. And lastly, it's going to provide us an endpoint for our applications to send traces to and logs to flow through. And so this is going to be our jumping point for all the information that we're going to be using later here in the webinar. And then lastly, we have the application itself. And so I'm going to skip some of the files in here because they're for a little bit later. But now I'm going to look at the definition for the task that is our application. And so right now we're defining our application as a large single task. You might actually break that apart as the application scales. But again, it's similar to how you would see a Docker Compose, where we've got our resources and constraints. We've got a Docker image that we're passing in here. And so as you're building your application, iterating on this might actually be a commit SHA, it could be a date, it could be a semver, whatever mechanism that you're going to use to identify which version of a container to run. And I've got some variables in here that allow me to spin the demo up quickly and just pick different versions. Again, we're injecting environment variables for the containers environment. And then we've got some different labels that we're associating it with it in Docker. And I want to highlight these three different labels because they reflect some tags that are really important to Datadog. So all of the information that comes into Datadog includes metadata in the form of tags. And those tags are what we use to correlate different pieces of information together. So you might have a trace and a log, and we need to actually combine them into one singular view. We use tags to do that. And so there are three really important tags within the Datadog ecosystem. The first of which is an environment, or env. And an env is a collection of services. And so here we actually have a service tag that's going to identify this particular application. And so this container is our front end. And so the services store front end. And then we've got a version tag. And the version tag allows us to have the same service evolve over time. And so we can actually compare how the performance or regressions might have occurred between different versions of a service. And so those services and those versions are all combined under the env umbrella. And so that's going to become really important as we get into the Datadog view. But just quickly kind of scrolling through the rest of our task here, we've got our discount service. Again, some environment variables that we need. Those tags again, things like port mappings, database. So I'm going to scroll all the way back down. And then we're actually going to deploy this application as a service, and we're going to associate it within different ECS clusters. So here I'm actually getting the identifier for the ECS cluster, which is in this particular environment. So again, either development or production, finding the associated ALBs, the VPCs, and then we're actually going to create target groups for our application. And so because we have a singular ALB per environment, we actually create a bespoke target group for each instance of our application that we spin up. And then we have a listener rule with a host condition. And so we're also going to create Route 53 rules that give us a unique name for a particular deployment, which is going to be based off of our workspace that we're using in Terraform. And so we might actually extract if it's development or production based on a naming scheme, and then a friendly name for that particular environment. And then all that gets tied together with our ECS service itself. And so you can see that there are quite a few moving parts to building out an ECS infrastructure. Having it in as code makes it really predictive, and then it also allows you to share and reuse that across multiple teams. And so again, our Storedog folks have done all this heavy lifting. We're deploying our application with Terraform, and so we're actually able to use this as we start troubleshooting issues that we have in production. So I'm going to jump back over to our web browser here, and I'm going to start within Datadog. And so here we're just looking at a default landing page within Datadog. You can see there's not a whole lot of information here to tell what's going on. The Storedog team is new. And so the first thing that the operations team is going to do is get ourselves hooked into AWS from an account level perspective. So we're going to look at our integrations and see that Datadog has a whole lot of integrations available out of the box. And so my demo is already set up, so some of these things are already going to be green. So you can see that we've got the AWS integration in place. We've detected that some nodes are running SSH. There's also application level things that you might find on particular servers. And so we're going to look at the AWS integration specifically. Again, I've already configured this for my account, and so I'm not going to click mine because I don't want to leak my AWS credentials. So I'm going to show what that would actually look like when you do that for the first time. So I got a quick little screen grab here. We're going to go ahead and click install on the AWS service, hit configure, and then we're going to link an AWS account to Datadog. And so we actually do include CloudFormation templates out of the box with our integration. So when you click that CloudFormation template, it's going to create a stack wizard for you within AWS that'll actually allow you to go through and build out all of the requisite IIM roles, our shared external ID, secrets, things like that. And so because my Storedog organization was already using Terraform, we built that out in Terraform earlier, but this is kind of the end result of that, where we've got our AWS IIM role that was created by Terraform, the external ID, which was generated by the integration, and all of that tied together. And so Storedog here is now hooked in with AWS and Datadog. And so the operations team is able to start getting some information about how their AWS infrastructure is functioning at a high level. And so I'm going to go ahead and go to dashboards. I'm going to open my dashboard list. And I'm going to look at some out-of-the-box dashboards that we include with our integrations. And so again, the Storedog team is new. They're not necessarily familiar with creating different dashboards. So we're going to look at some of the ones that come directly out of the box so they can use those as starting points. And so here's an ECS dashboard. I mentioned that our ECS infrastructure has been running for a little bit of time. So we actually have some high-level data here about how ECS clusters are working, how's our task load, how's the overall resource utilization of our clusters. We also have some information at the EC2 layer. So again, some high-level status, how many different EC2 instances may be running, what's their CPU, what type of instances are we using. I'm not using a whole lot right now. So here's like some network level traffic that comes there. So again, this is a starting point on how you can actually start building dashboards and grabbing information that are relevant to your needs. And the last one I'm going to highlight is our ALB dashboard, because there's actually a lot of kind of cool information here. So account-wide, we see that we actually have 4 healthy hosts. We have some pretty high average response times. We can see our traffic that's coming in. We're getting a lot of 500s. We're looking at, all the different connections that may be active or coming in new. And then we actually separate this out between production or development. So I'm actually just going to look at that production environment. See, we actually only have 1 host that's responding here. It's latency. If I switch this over to development, we're going to see that we actually have 3 different development environments and how their metrics are going. So this is kind of the first view into where these tags start coming into play. So the Storedog team didn't have to do anything on the hosts themselves. This is just the integration that you get directly by hooking AWS and Datadog together. But because we do have the agent running on the EC2 instances, we also do have system level metrics that we're getting from the devices themselves. So we can actually look at our infrastructure list. And this is showing us our compute resources that are coming in from our AWS environment. And so we can look and see that there's different applications that are associated with these nodes, how their resources are looking. I can inspect a particular node and get some information about it. And so we can see some tags here that are coming in for that particular node from the AWS integration. Again, these tags are actually how we're going to slice and dice data later, as well as correlate it with other metrics. So here, like, for example, here is the region that this particular EC2 instance is in. This is this auto scaling group, it's AZ. We also have some system level information that's coming from the Datadog agent. And so what's its platform, its CPU, as well as logs that are coming from the system itself. And so I'm a very visual kind of learner. And so I actually like to look at our list of hosts as a map. So again, these are compute nodes that have the Datadog agent installed and running on them. This is by default broken down by availability zone. Because we're so ECS centric here, we're actually going to break these down by ECS cluster. And so here we actually have the production cluster and the development cluster. And we can see that there's some color coding here. This is actually our CPU utilization, and this is relative to the group that we're seeing here. So we actually only have about 18% utilization on the high end. But from here, we can actually drill in and look at this host. Again, we can see that same set of tag information, the system level facts. Then I'm going to use this as a jumping point to see a dashboard for this particular host and see how it's performing as a system. So here we're getting CPU usage, process, load, network, disk latency, all of those system level metrics that tell you the health of that particular compute node. And so the Storedog application we know was running slow. It was seeing some errors. I'm just going to go ahead and click refresh on this to prove the point that it's taking a long time for these things to load. The operations team is going through and looking at the system level metrics that we're now getting from integrations, and they're not seeing anything obvious. So the compute nodes, the network latency, everything is appropriate from an infrastructure standpoint. So now the task is to try to figure out what went wrong or what might be going wrong in the application itself. And so the ops team works with the development team to get application performance monitoring enabled for their application. For the Python code base, it's just adding in some different invocation. For the Ruby code base, there is a little bit of code changes required. Again, for the sake of time, I'm not going to go through the process of building out an APM integration. If you want to get more information on that, though, we do have some interactive labs at learn.datadoghq.com that you can sign up for free, and that'll actually walk you through that process. So now I'm going to go to our APM landing page, and we'll look at our services. And I'm going to switch over to the production environment. And so now that we have APM enabled for our application, we're leveraging the different tags such as environment and service. Now we're actually able to start understanding the state of our infrastructure and the state of our applications in one view. And so here right out the gate, I can see that the store front end has a high error rate, it has high latency. our two microservices has some fairly high latency. Again, I'm a very visual person, and maybe I'm in operations and I don't necessarily understand the interrelationship between these services. We can look at this at a map view, and we can see, again, how this application communicates within its various components, as we saw earlier in the slides, which is where there's a screen grab from. I can click on a particular instance and hover over and see the traffic flow. So the store front end is hitting the cache, it's hitting the microservices, it's hitting a database, it's flowing through. So we can actually see all this interrelation between these particular services. And so from an operations standpoint, we're now starting to get some really useful data. But again, the operations team is a little bit divorced from the development of the application. And so their goal is to be just proactive on the monitoring while we start working through these issues. And so as an operations team, we don't want to be taken by surprise if our state degrades even further. We've had a pretty consistent baseline of performance recently, but we're going to create some monitors to alert us if things change. And again, the Storedog team is kind of new to Datadog. And so we're actually going to use some of the suggested monitors that come right out of the box with Datadog. So when I click that suggested monitor, I see a handful of suggestions. I'm going to go ahead and enable some of these monitors by default. So high P90 latency, high error rate, and high average latency. And so we as an operations team want to know if our latency gets too high, if our error rate dramatically increases, we want to be notified of those changes. And so I'm actually going to go ahead and edit one of these default monitors that we created to help you kind of understand how a monitor is built. And so over the past 4 hours, this has been the duration of our requests coming in for the front end. So it's a rack application, the request and the duration by service. So this is limited to the store front end. And pretty consistently, we're seeing 4 to 6, just shy of 7 milliseconds. And so we see that this is all coded red. So by default, we actually include some thresholds. And I misspoke, I said milliseconds, those should be seconds. And so by default, we actually have some alert thresholds here that we think as Datadog should be appropriate. Obviously, we're in a degraded state that doesn't reflect reality. So what I'm going to do is change this to warn us at 7 seconds and alert us at 8 seconds. And to make this a little bit easier to view, we're going to scrub out the peak when we restarted the application. And so now we can see that we would be in an alerted state with this particular metric. We would not actually go all the way up to like a critical or a warning. And so we're going to save this as it is here. We're going to go down here and look at the notification of our alert. And so if our P90 latency gets too high, we'll throw a warning. If it gets way high, we're going to throw an error, and we're actually going to notify Rick about that. And so this is great. It's awesome. We built this out. We've saved it. And that builds these monitors for the store front end service in the production environment. Now we could go through and click all of the different services that we want to monitor and do this whole thing over and over, but that's not really the best use of our time. It also means it's a very manual process to create monitors for additional services within additional environments, right? We actually want to be proactive as an organization. And so we can export a created monitor. So here we're actually hit export. This is going to give us a JSON view of that monitor. So here you have things like the query. So this is actually how we're building out that by gathering metrics from APM, the message that we're using to notify folks, as well as our thresholds. Now we could take this and dump it into a text editor and then change the variables you want and load it back into Datadog, but that's not very scalable either. And so the team has been really committed to using infrastructure as code. We're using Terraform. And so we're actually going to use Terraform to create these monitors as part of the deployment of our application. And so I'm going to jump back over to our Terraform code. We're going to take a look at how to build those monitors. I'm going to start with the variables that we're using to feed into our Terraform code because I think it makes it a little bit easier to understand how that code works. And so I'm going to start with some autovars here. As I mentioned, we are using workspaces within Terraform. These are representing our default values that we're going to use in our particular block of code. You could actually override this as you feel fit with various mechanisms inside of Terraform. But here we have a map of services. We have our store front end, we have our discounts, we have our advertisement service, and the framework that they were running in. So when we looked at that query, we were actually specifying rack for the Python things, we're using Flask. And then we have our thresholds that are actually reflecting what we want as a business. So these are the thresholds that reflect our SLAs. You can see they're quite a bit lower than what we have in production today, but this is how we're going to build our monitors moving forward as we troubleshoot. I'm also going to call out a couple other kind of like cheater variables that I've been using. So we have this concept of our environment. We're actually splitting this from the naming scheme that we've chosen for our workspaces. So for our application, we have an environment hyphen friendly name. And so it's either going to be production dash something or development dash something. And that's actually how we're going to build these things out. And then I've also got a Boolean variable about whether or not we want to create these monitors as part of the Terraform run. This might be useful for the team that's just trying to quickly build something up and test one bespoke thing. Or for me, I was building the webinar and I didn't necessarily want monitors always deployed. And so that's going to feed into the monitor definitions here. So we actually have 3 Datadog monitor resources within this particular section of Terraform. So we have one for our high error rate, we have one for our high average latency, and then we have another one for high P90 latency. So that P90 latency is the one that we were editing by hand. We can actually see that if monitors is true with that Boolean value, we're going to iterate over that map of services. And so we have the 3 services in there. For example, store front end. We have an environment based off of our Terraform workspace. So development RIC. And then we've got some logic here about how to handle the alerting. And so what I've done here is it says that if we are in production, we actually want to send alerts to Slack if we hit a warning. Although if we're not in production, we actually don't want to do anything. So this was built right now for the operations team. As the development team starts to adopt including monitors as part of their development process, they might actually want to send it to a different Slack channel. They might want to notify the owner of that environment directly, or they might want to do nothing. Additionally, we actually have some re-notifications. So if we are in the production environment and an issue has not been resolved after 30 minutes, we're going to send an escalation. In this case, we're going to send it to PagerDuty, again, only when we're running in production. So this is where leveraging these different workspaces, leveraging these different variables allow us to build dynamic monitors that fit our particular use case and environment. And so this is the extrapolated query that we took from the export. We filled in and switched out the framework. So maybe it's rack or maybe it's Flask, workspace for the environment, the service name, and our different thresholds. And so we're actually able to use this to deploy our application and our monitors directly into ECS and into Datadog. So the team has gone ahead and worked with the developers, and we've actually spun out a new infrastructure within ECS for development. So I'm going to switch my environment here to development RIC. And so we've been working together with operations. We deployed the exact same code base that we're using in production. We included the monitors that we've agreed upon, and we can see here that those monitors have been alerted. So I can actually click on one of these monitors and see that we definitely triggered high latency, high average latency, high error rate. Going back here to this view, you can see that we still have that high error rate here articulated. We have the high latency articulated here. But if we look at the map view, we now have some correlation about some of the downstream services and how they might be impacting our front end. And so the store front end definitely still has high error rate and high latency. Our supporting services, though, also have some high latency, but they don't really have high error rates. And so this is going to help us understand how to go a little bit further into the development and debugging process. And so with application performance monitoring turned on, we're now getting traces from our application. So as different users are hitting the web front end, we're following that request all the way through the code path of the front end, through the microservices, through the data stores, and we're gathering information about what's going on there. And so here I've had some traces. I'm going to look at errors only. We want to focus right now on errors because those are breaking our user experience. I'm going to click the first error trace that I find. I can see that the request comes in over HTTP. We're trying to get the cart. It goes into this particular endpoint. gets to this endpoint, and now we see that there was an error from the application itself. And so this particular Rails front end was throwing this error on this particular ERB template. And that's actually correlated as well with the logs on that system. So we are writing this to the log on the file on this particular host. And so we can see that all of this information is correlated together through the use of those tags. And so for the sake of time, I'm going to not necessarily look at all of these different errors because they are admittedly the same. But from the development team, we're going to go through, we're going to look at that ERB template. We're going to look at the line that was indicated and see that there's some issues with our code as determined here. And so we're going to work with the development team and get that sorted. And so we're going to spin up a new version of that environment to look at those. And so I'm going to jump over to Tyler's environment, and we're going to continue our troubleshooting. And so Tyler has gotten the fixed code from the front end. The error rate is much lower. It's not 0, but it's within our threshold, but our latency is still high. So we're going to take a look at some of the requests that are coming in on this particular environment. We can actually see the latency distribution, the different endpoints that are being called. We're correlating that in with the different metrics of the systems themselves. Again, the CPU, the memory, network disk, everything from a system level service seems okay. So we don't think that's really the source of our latency. We're going to sort our requests by their average latency. Looks like the home page is taking a ton of time. We're going to click that endpoint. Again, get some information about requests versus errors, the latency, how long things are taking, some information about spans. And then here are some traces for this particular environment, front end and endpoint, kind of all put together for us. And so I'm going to grab this one here that looked pretty high in terms of latency, and that's going to load with this flame graph again. And so this is where we actually have the request coming into the front end, how it's flowing through the front end, and then through our different microservices. And so Tyler's environment, we see here that we are calling out to the discount microservice and the ads microservice. And discount's taking about 3 seconds, and the ad service is taking about 2.5 seconds. And so looking at the discount service, we see there's a big gap of time where nothing happens, and then this big purple bar. And if we actually zoom in on the purple bar, we can see that there's a ton of these Postgres queries. So because we're integrated with all the different parts of the stack, we're actually seeing what's happening within the Postgres queries themselves. So we actually get that information, and Tyler thinks this is probably an N+1 issue. He's not necessarily a DBA, so he's going to work with some other folks on the development team to get that sorted. But he's going to continue to dig in to see why these requests have long response times. So looking at the ad service, we can see that's taking about 2.5 seconds, and it's calling ads.status. So we're looking at the ads code. Jump over here to the ads code quickly. I'm going to scroll down. I'm going to find our ads status function. And looking here, Tyler finds that there are some extraneous sleep statements left over. So as part of the development process, we put in some weird waits, some weird sleeps, and they leaked out into production. And so by using the APM tracing, we're actually able to identify different parts of our code that are not performing the way we anticipate. So Tyler actually works to get those errors corrected. He works with Megan to deal with the N+1 issue. We go back over to our environments and switch now to Megan's environment. And we can see now that things are starting to look better. So the error rate is low. The latency is still maybe a little bit higher. Maybe put that down to the last 15 minutes. So yeah, still some higher latency in Megan's environment. We're still alerting. So that's just on our average latency. We start breaking down and see what's happening here. But the application now is running in a way that we find to be acceptable. We jump over to Megan's environment, give it a quick refresh. We can see that the page loads really quick. We're able to go look at an item, throw it into our cart, and everything looks to be functioning the way we anticipated. And so I know we're getting kind of close on time, so I'm going to kind of recap some of the key concepts that we just talked about here. So we're deploying our infrastructure with infrastructure as code. We're deploying our application with infrastructure as code. And now we're including our monitoring and observability with that infrastructure as code. And so the goal here is so that as our development teams are spinning up their own instances, their own development environments, they have a vested interest in the performance of their applications. They have a vested interest in the information that's coming in to the monitoring and observability platform. They're able to actually get application level traces, correlate that to the system, and really work to holistically manage their environments moving forward. And so with that, that's kind of the end of the demo. I know we're gonna have a little bit of a Q&A here. A couple closing points. I believe after this event, we're gonna send out some information on our raffle. And so 1 in 5 folks are gonna have a chance to win an iPhone. And so to do that, you actually sign up for our free 14-day trial and complete a couple basic tasks. The only way you're eligible for that drawing is if you sign up via the link that's gonna be sent out. You can't do that directly from the website. I mentioned the learning labs at learn.datadoghq.com. So those are free, they're interactive labs. They teach you some basic things like monitoring observability. They teach you different ways to integrate with Datadog and use Datadog. And then lastly, if any of this seems really interesting to you, we are hiring. We've got a ton of different openings and recommend you check us out. So I hand that back over now to Mike and we'll take care of some questions.
All right, hey, that was awesome. Let me jump into one quick question here that showed up almost immediately. You were focused on Terraform, but people want to know if there are other configuration tools that you support, specifically CloudFormation or anything else that's on the list.
Yeah, so we definitely support multiple configuration management tools. CloudFormation is supported. You are able to create monitors and your infrastructure stacks. I just highlighted Terraform because I'm a little bit more familiar with it. There also is varying degrees for some of the other tools as well, but may not be able to do as much as Terraform and CloudFormation.
All right, awesome. I want to encourage everybody to ask some questions, and let's take one from the audience that just came in. How are you monitoring metrics from AWS integration, given that it has a 10-minute kind of polling interval?
I do believe that we do have a little bit of a delay in that. I'm not intimately familiar with how that affects our dashboards, but I do believe that there might be that 10-second delay.
Okay, well, since you mentioned dashboards, how are you managing dashboards as code is another question we have.
Yeah, so in the similar way that we were doing monitors, some of the configuration management tools do allow us to build and export dashboards. And so if I were to look at a dashboard, I actually just jump over to a dashboard list. I'll grab the ECS dashboard, for example. You can export a dashboard as JSON. And so that exported out the JSON file. We can then load that into a text editor and make changes by hand. We can load it into different configuration management tools. And you can make that as part of your development process. And so I didn't really get a chance to go through how we might build different dashboards. But the purpose here is that the team would actually start putting together metrics that reflect the health of their business that make sense to them. So it could be a combination of infrastructure statistics, it could be a combination of application performance, and it could be just some information that helps them with their runbooks.
All right, sweet. Our next question goes to how do you manage changes to the monitors going forward, and what happens if someone edits them from the GUI and somebody else is in some other different interface? So how do we all keep things synchronized?
Yeah, so that's kind of the common DevOps culture problem, right? Where we're actually maybe mismatching things that are being done programmatically versus things being done by hand. We do have the ability to lock our monitors based on the owner of them. And so you might actually say that things that are created with the infrastructure as code are owned by a certain service account, and those can only be managed via that infrastructure as code tool, and then managing those variables, those monitors in your source control. Depending on your tool, you have different levels of ability to detect existing resources. So it is a technical problem, but it's also a cultural thing you have to kind of ingrain on how you want to work as a team.
All right, the next question is a little more philosophical, but do you think this whole shift to microservices is creating something of a moment in time where we're going to shift from classic monitoring to observability? And what is the difference between monitoring and observability in your mind?
So I think there's kind of a couple layers to the question there. Obviously, the shift to microservices, the shift to containers is drastically kind of changing the way we look at deploying applications. I think monitoring and observability, when you break those apart into two things, monitoring, if you look at more of the traditional metrics about how that infrastructure is performing. still has some utility, right? We're deploying things with Kubernetes, we're deploying things in ECS. There is some level of metrics we can garner out of that to see how that stack is performing for us. But the observability piece kind of crosses all of those boundaries. It's the application itself. How are the code that you're writing is performing and interacting with the other pieces of code that you've written? And so I don't think that as we go into microservices that really changes. I think it actually becomes more important because things are broken apart and distributed.
All right. Kind of as a follow-on to that, do you think the way the IT team is structured is going to be changing because it's going to look more like DevOps everywhere versus a small individual team? As it seems like the security people, the IT people, and the networking people all need to work a little more hand in glove. So how does that look to you?
Yeah, that one cuts close to home. So I previously worked for a infrastructure as code vendor. I spent a lot of time in the network automation space, and there are definitely still very big silos, both from a cultural standpoint, but also from a technology standpoint. And so those different groups, network or security, the applications team, they have different needs. And so I think that the best thing we can do is to provide tools that help them at least communicate on problems in a common language, maybe not necessarily solve all of their problems individually. I do think it's a long slog before we start seeing how these different teams are going to coalesce into one in the future. I would love to see everybody, playing together in the same way. It just does seem a little bit far off to me as a personal answer.
All right. Well, at the very least, maybe we could be talking about the same thing at the same time. That would be great.
Yeah, that would certainly help.
Next question kind of goes to most of what your presentation is focused on is AWS, but I'm assuming you're going to support other clouds. Is that on the agenda as well? And where are we in that capability?
Yeah, so we definitely support a lot of the common cloud platforms with out-of-the-box integrations. I personally not really familiar with some of using the other ones, so I focused this on AWS, but I do know that the team as a whole is definitely leveraging lots of different platforms.
Well, without getting into a lot of detail there, I'm just wondering, is Datadog always going to be used for something that's more troubleshooting, or will people start to use it to evaluate which platform makes the most sense for a different type of workload based on what they've historically seen through the dashboard and the monitoring capabilities?
Yeah, so that capability is there today. Like for example, we could look at some of the billing information for AWS with Datadog. I mentioned kind of the spiel about the company. That is our goal, is to enable everybody in the business to use metrics and data to make business level decisions and understand how things are interacting. And so the dashboards may or may not be there out of the box, depending on what you're looking for, but that information can be translated to business level metrics. So that is definitely a desire. It's a use case. I'm just not necessarily familiar with what you get out of the box versus what you may have to build.
All right, cool. And are you seeing maybe end users looking for dashboards that are specific to an application or some sort of view that they want that's not as IT driven, that the IT guys give them in order for them to kind of have some visibility into the environment, but maybe not so overwhelmed by everything that they could look at?
Yeah, actually, interestingly enough, we had our user conference in August, and I forget the company that had a talk around this, but they actually were showing conversion rates for different activities in their platform, and then overlaying that with some A/B testing or some code changes that they were doing. And so they could actually use that conversion rate or some of those user behaviors to justify doing something or not doing something. We also have real user monitoring, so we can actually track and see how your customers are using your web properties, what different features they might be clicking through. And so there is some of that higher level information that you can make available as dashboards for the business folks, for the people that might be controlling the purse strings.
All right, cool. Well, I want to encourage folks to ask a question here because Rick is hands-on expert in the space. And I guess the only other question I might ask you is, Kubernetes, we see a lot of it. I don't know if you've seen it on AWS environments lately, but it does strike me as one of the more complex things that has come down the pike in recent history. So what's your general impression of what what does monitoring in that environment require? I don't know if you have any experience in that space, but what have you seen or heard?
Yeah, I personally actually don't do a whole lot with Kubernetes. It's kind of like a I feel like at this point a personal weakness. I feel like I've started to age into being a little bit more of a grumpier old man and not necessarily getting into the new stuff as quickly as I'd like. We actually do use Kubernetes quite a bit as a company. We do have a lot of information out there in our different webinars and Datadog On series about how we're monitoring Kubernetes. A teammate of mine, Ara, has done quite a few talks around that. So we do have a lot of information out there for some folks who are a little bit more up to speed than I am.
All right, cool. Well, there's probably a whole bunch of content between DevOps.com and Datadog.com that people can check out to figure out what the next wave of things is going to be. Hey, I want to thank you for spending some time with us today, sharing your expertise. That was awesome.
Awesome. Hey, I appreciate everyone's attendance and thank you all for putting this together.
All right, and we're looking for some winners of the the Amazon gift certificate. I think that they're coming up shortly, but while we're waiting on that for one more minute, I'm going to give a shout out to this raffle that you guys are doing, just to remind people that I don't see everybody giving away an iPhone 11 Pro very often, and a 14-day trial doesn't seem like it's a heavy commitment. So
the odds are pretty good too. I think it is 1 in 5. So
wow.
I would take one, but they won't give it to me.
Those odds are pretty good, I would say. All right, well, I think we're going to alert our winners as to who's going to get the Amazon gift card in email. But hey, thanks everybody for spending some time with us. Oh wait, this just in. Amazon winners are Amy G, Bill G, Brandon K, and Elaine D. All of you guys are going to get your gift card sent to you by email, I would assume, and congratulations to our lucky winners. And once again, Rick, thanks for being on the show, and we'll see you all guys next time.
Thank you again. Cheers.